In question 8 here, we've got some practical applications of differentiation. So let's read the question. So after flying a short distance, an insect came to rest on a wall. Thereafter, the insect started crawling on the wall. The path that the insect crawled can be described by this function. H of t equals t minus 6 times negative 2t squared plus 3t minus 6. I'm just going to write that down so long before we do the rest. So h of t equals t minus 6 times negative 2t squared plus 3t minus 6. Okay, so there is our function, where h is the height in centimeters above the floor and t is the time in minutes since the insect started crawling. Okay, so question 8.1, at what height above the floor did the insect start to crawl? Okay, so it starts when time is 0, right? So we just make t 0. So we find h of 0. So that'll be equal to 0 minus 6 times negative 2 times 0 squared plus 3 times 0 minus 6, and we just solve that. So h of 0 equals 0 minus 6 is negative 6, negative 2 times 0 squared is 0, plus 3 times 0 is 0, minus 6. So h of 0 equals negative 6 times negative 6, which gives us 36 centimeters above the ground. Remember to write your units. That was that. So just for 1 mark, that's fine. Just substitute t equals 0, because that's when something starts, when the time is nothing. Then 8.2. How many times did the insect reach the floor? Okay, so let's think about what this means. So if the insect reaches the floor, what is its height above the floor? 0. So that's when h of t, the height, is 0. So all we do is we say 0 equals t minus 6 negative 2t squared plus 3t minus 6, and we solve this. So we know that either this bracket is 0 or that bracket is 0. So that gives us either t minus 6 equals 0, which would give us t equals 6. So that's supposed to be a 0, which gives us t equals 6, or this is 0, negative 2t squared plus 3t minus 6 equals 0. Okay, so you can try to factorize this, but it doesn't look like it'll work. So we can try to use the formula. So for that, we'd have t equals negative b plus or minus square root of b squared minus 4ac all over 2a. And now what we see here is there's a problem, because what is the b squared minus 4ac? Let's do this part first. B squared minus 4ac. So b, what is the b? B is that. So that's b, that's a, and that is c. Okay, so we've got 3 squared minus 4 times a is negative 2 times c is negative 6. So this gives us 9 minus minus minus, it gives us minus. It gives 4 times 2 is 8 times 6 is 48. So that gives us 9 minus 48. Right, so that is less than 0, which means no real solutions. No real solutions to that part. So the only real solution is t equals 6. And that's the 3 marks, is for getting this t equals 6 right, and for showing that our discriminant, or the b squared minus 4ac part, is negative, and we can't have a negative underneath the square root. That's why there's no real solutions here. Good. Then we can look at 8.3. So question 8.3. Determine the maximum height that the insect reaches above the floor. So anytime we hear maximum or minimum, we know that means we have to differentiate and set equal to 0. Right? Maybe just a quick recap of why that is. We can do that. Let's do that at the bottom here. So if we have any graph Let's say it looks like this. Okay, to find a maximum or minimum, so here's a local minimum there, and here's local maximum. So what is the gradient of the tangent? What is the gradient there? It's 0, right? And the gradient is the derivative. So if we set the derivative equal to 0, we'll find all the spots where we have turning points, and turning points give you a maximum and a minimum. So that is why we'll find the derivative and set that equal to 0. Okay, so h of t, actually I'm gonna do this at the bottom as well. Just rewrite h of t. We need a little bit more horizontal space. So h of t equals, we had t minus 6 times negative 2t squared plus 3t minus 6. Okay, let's multiply this out first. So we'll have h of t equals, so we'll multiply, do the rainbow multiplying, right? So t times negative 2t is negative 2t cubed. T times 3t is plus 3t squared. T times negative 6 is minus 6t. Negative 6 times negative 2t is plus 12t squared. Negative 6 times 3t is negative 18t. Negative 6 times negative 6 is plus 36. So let's collect our like terms. Cubes, there's only one, negative 2t cubed. The squared, so we've got 3t squared plus 12t squared is 15t squared. Then we've got, for the t's, negative 6 minus 18, that gives us negative 24t. And then we've got 36 as our only number, 36. Okay, so now we can find, if that was h of t multiplied out, let's find the derivative, h prime of t. Okay, so we know that the short method says you're welcome to try this by doing the first principles, but that'll take you a couple of pages, I'm assuming. Okay, so 3 times negative 2 is negative 6, negative 6t, and then 3 minus 1 is 2. Okay, I'm just going to write that slightly neater and not have all those dots there. Let's do that again. So 3 times negative 2 is negative 6t, and then 3 minus 1 is 2. Then we've got 15 times 2 is 30, and then 2 minus 1 is 1, so we don't have to write that one. Then we've got 1 times negative 24 is negative 24, t to the power 1 minus 1 is t to the power 0, which is just 1, so we don't have to write anything, and any constant just becomes 0. So here is our derivative. Now we want to set that equal to 0 to find a maximum or minimum. So 0 equals negative 6t squared plus 30t minus 24. This is just solving a normal quadratic trinomial. I'm going to first divide everything by 6 just to make it slightly easier. So 0 equals negative t squared. Actually, I'm going to divide everything by negative 6 to have a positive t squared. So t squared minus 5t plus 4. Okay, we can factorize that, gives us t minus 4 and t minus 1. So that gives us that either t minus 4 equals 0, which gives us t equals 4, or t minus 1 equals 0, which gives us t equals 1. Okay, so those are two options. Now let's see, what was the question. Determine the maximum height that the insect reached above the floor. So the maximum height will be the biggest one, that is this guy. So our answer would be 4 centimeters. Alright, no, that is incorrect. Our answer is when time is 4, right? Almost made a mistake there. So this is not 4 centimeters, this is when time is 4. So after we know that time is 4, we substitute that back in, or we do both of these, right? T equals 1 and t equals 4. That's when you reach maximum heights, or local maximums. So we do h of 1, so that'll give us 1 minus 6 times negative 2 times 1 squared plus 3 times 1 minus 6, and we've worked that out. So 1 minus 6 is negative 5. This gives us negative 2 times 1 is negative 2, 3 times 1 is 3, minus 6, so that's negative 5 times, that gives us negative 8 plus 3 is negative 5, so that gives us 25 centimeters. So that's one option. Now let's try when t equals 4. So when t equals 4, so let's do h of 4. So that gives us 4 minus 6 times negative 2 times 4 squared plus 3 times 4 minus 6. And what does that give us? 4 minus 6 is negative 2. And we've got negative 2 times 16. So that is negative 32 plus 12 minus 6. And we get negative 2 times, so negative 32 minus 6, negative 38 plus 12 is negative 26. And negative 2 times negative 26 is 52 centimeters. So that is the biggest one, and that is our final answer. Right, so I almost made a mistake because I didn't check my units. This was t equals 4 or t equals 1, and we wanted the maximum height. So this is when the maximum height is, and this is the maximum height. So that's one local maximum. Here's another local maximum. Right, so 52 centimeters, that is our final answer. And again, please, if you've done anything in another way or want to find out why we did something a certain method that I did, please ask in the questions below and we'll discuss that. Thank you.